I can't say things which are not to be said. Okay. So before we move on and before we look at statistics, let me introduce myself. Let me also introduce the right? And I would love to hear from you guys as well as what are your expectations out of this specific course, not the entire program. My name is Abhishek Vashist. I am a faculty with TETA, Masters Union. I am also an associate editor at TETA, which is a sister concern of Masters Union. I hope you guys know about it already. I have done my PhD in operations and quantitative techniques from Indian Institute of Management, UP. Then I worked with OB Jindal Global University for around 3 years. Then I joined IIM Shillong for around 3 years. And from IIM Shillong, I came to Masters Union. I worked with Masters Union for around 3 months. Then I got shifted to TETA. And then I've been here for almost a year now. I take statistics. I also take operations research, operations strategy, project management, TQM Six Sigma. I'm a black belt in Six Sigma. I am also an auditor for ISO 9001. And 9001 is quality management system. So I audit firms for ISO 9001. But my research is mostly in the domain of quality management. And I have been teaching statistics for almost 10 years now. And one thing that I've realized over these 10 years is, so I started teaching statistics like how it should be taught, formulas, numbers, a lot of mathematics. And what I realized was that neither me nor the students were having fun. So over the time, I have changed a lot. And now it has come to that point where the only mathematics that you'll see will be either the number of students that are there at 24. I don't see any other number on the screen. Right? So you'll be seeing some numbers, but then I promise you that we'll not be doing maths. The idea is not to do maths at all. And if I am doing maths in this age, I am a fool. Why? Because you have software, you have AI, you have what? Then what is the need of understanding statistics if you are not doing numbers and you're not playing with numbers? What do we do with statistics? Idea is to interpret things. The idea is to know how to make sense out of the numbers that we have got. Idea is to understand the patterns that are there in the numbers. The idea is to take decisions on the basis of the data that you have. That's what we'll be doing. Now, I will try my best to make the class fun for those who are online and for those who are here. Fun as in I'll be narrating stories, we'll be playing games, we'll be doing a lot of activities in class. But if I am doing things and I'm putting in effort, I need some things from you guys as well. So there are some rules of the arena. There are some rules that we'll have to establish and play by, right? So the rules are simple. I give you liberty. Liberty of saying anything in the class. Liberty of doing anything in the class. Now, when I say anything, does not mean anything in the world. Things that you can do in class, okay? As soon as I say you can do whatever in the class, somebody like, you just said you can do anything in the class. That's not the case, okay? When I mean do, you can do like what Ma'am is doing, maybe looking at laptop, and that means that I am boring. Just tell it. Oh, wonderful. Making notes saying that the professor said you can do whatever in the class. This is also fun. Right? So, if the class gets boring anytime, you stop me and tell me that, it is getting boring. We are not liking this topic. We are not liking the way you are introducing this topic. You can always tell me that the class is getting boring. We are not liking the way you are introducing this topic. We are not enjoying. I'll change. I can, time to post a little. So I can teach one topic in 10 different ways, right? So I'll do some other way. But you can stop me, you can tell me whatever. I'll not take it otherwise. But that also gives me some freedom. I can also say things. I can also say whatever You also should not feel bad. I can roast you. You can roast me back. That is perfectly fine. I'll not mind. Now, the idea is that we will have a two-way interaction going on in the class. Fun, banter, roasting, whatever it is. But then we should be serious about what we are learning. I will be okay if you do not learn everything in statics. I'll be teaching 100 things. Out of those 100, if you know everything 80%, I'll not be happy. But if you know 80% of the things, 100%, I'll be happy. Getting what I'm trying to say? Right? So if you are in the class, paying attention on a specific topic, pay attention. If I'm looking at you, I should see you, or I should have you looking at me. Whenever I look into your eyes also should be looking at me. If you want to talk to a friend, want anything, want to do anything, just raise your hand and tell, I want to talk to him for 2 minutes. Then you go out, have fun, chill, come back, no problem. Right? If you want to do anything else, you just tell me, I want to do this. Right? Another thing is, if you want to go out for nature's call or any other break, you go out, I don't have any problem, but the time limit is 7 minutes. If you're not back in 7 minutes, you will be marked absent. I might not allow you in the class again. I might make you do things which you might not like doing. 7 minutes is fine. All of you agree. 7 minutes is not enough time to attend to nature's call. These are the rules. Other than that, I don't really mind if you want to drink coffee or tea in the class. I was about to say anything in the class. You guys are grown-ups. You can have whatever keeps you alive. Maybe Red Bull or whatever, right? You can have. Until unless the boss is there, they allow. Right? It's up to them completely. Yeah, that's it, more or less, I guess. We'll try and, statistics is a subject which if you don't practice, you will not understand, right? I'll be suggesting you a few books on the go, right? And I'll forget sometimes. So if I'm suggesting any book, please write it down and make it a point that you read the book on weekends or whenever you have time. We can see your hairs whenever you have time. But please read these books. These books will make your understandings wide, right? You'll be able to understand things from 10 different angles. You'll be able to think about things which you might have never thought, right? So these books are more to open your mind, right? Anybody, any doubt? Online, here in the class? Anyone who wants to say anything or to ask anything? Yes, sir.
I barely get time to read book per se, so any alternative would be.
अरे सर आजकल एक चीज होती है
ChatGPT.
लाल नहीं एक लाल रंग का ऐसे एक होता है उसके अंदर यूं प्ले वाला बटन होता है
Okay, so you.
वहां पर आप लिखेंगे समरी कोई ना कोई भाई होगा you will find a content creator who would have made a summary of that book. If not, yeah, you do it. Read the book, make video, post it. Who knows, you might, YouTuber. At least the amount of the book that you spent, you will recover from YouTube. No, so that's the only thing. You find summaries. Still, if you are not able to get it, then you talk to me. I'll discuss that book. I most probably would have read the book that I'm recommending. So we'll. Right? Okay. One thing is, if I roast or if I don't roast. If I am cracking something, if I'm saying something, don't take it away. No? This is a promise. Whatever happens in the class stays in the class. Although it is getting recorded, will spread like anything. But whatever happens in the class stays in the class. Right? Shall we start? Yes. Are we all good?
Yes.
People are online. Can I hear yes or no?
Yes, sir.
Yes.
Yes, yes.
Yes, sir.
Yes, sir.
Yes.
There was a girl who was very seriously yes. 2 bribes. Very good. Okay. Okay. Now, what is statistics? Should be the first question, right? What is statistics? Anyone? What is statistics?
Study of quantitative data.
Study of
Quantitative data.
quantitative data only. You can't study qualitative data using statistics. Let's take examples. Let's say I talk about genders. Gender is qualitative or quantitative? Qualitative. It's a categorical data, either male or female. Now I have 5,000 people. Out of 5,000 people, let's say 3,200 are female, 1,800 are male. So qualitative data, but then I have a statistic, right? Need not be quantitative data only. But what he's saying is that it's study of some data. Now, studying the data is not exactly statistics. I would say statistics is summarizing the data. Right? You are summarizing the data. You come up with a summary of the data. Now, just now I said there are 5,000 people, 3,200 female, 1,800 male. What is this? Summary of the entire data that I had. Right? If I have 2, 3, 4, 5 columns on the data, let's say if I have their income groups as well, I have their age, weight, height, I have their gender. Now what I can do is I can find average age, mean weight, right? Can I? I can find mean height, weight, age. I can find out how many are male, how many are female. I can find out how many are falling in what group. This is summary of the data, nothing else. Mean is nothing but the summary of the data. Now, summarizing the data is statistics. Now, what is data? Summarizing the data is statistics, but the question is, what is data?
Unorganized information.
Information.
Unorganized information.
Wonderful. Unorganized information, any sort of information that I have is data. But information on what? What sort of information? Information on what? So let's say if I ask him that, how many hair do you have? He'll give me a number. That is some information for me. Versus if I ask him how many hair do you have on your head, he'll also give me a number. Random people will give me random numbers, right? But then this is information for me. This information is on a specific thing that I asked. Specific thing. What was that specific thing? Number of other hair, right? So this specific thing becomes my variable. The characteristic which I am interested in, right, is the variable. Now the characteristic that I am interested in is the variable. Whatever information I collect about that characteristic become my data. And if I summarize the data, that is the statistic. Simple. 3 things, 3 words you'll remember. Let's see if we have it on the slides. So I told my friend here, my bosses, that I will not be using slides. They took it seriously. They did not. You will not be using slides. Why do you need slides? They don't know that I don't remember the terms. I need the terms on the board. But then this is what we are talking about. If you see, right? Variable is nothing but characteristic that we are interested in. Data is nothing but the information on that specific characteristic. And when you summarize that information, that becomes the statistic for me. Now, the wonderful and the best thing about statistic is that it can be of multiple nature, right? When you're summarizing things, you can summarize things in multiple ways and using multiple tools, multiple methods. For example, let's say I'm talking about cricket, right? IPL is about to start tomorrow. Today. Oh, today is Saturday.
Yes.
Oh, yes.
Yes, sir.
So RCB versus Sunrisers, right? Now, let's say I want to talk about who has won the trophy how many times. There are multiple ways in which I can show this. I can make a table with all the teams mentioned in column 1. So I can make a table where in column 1 I put names of the team, right? CSK, MI, KKR. And then I write the number of times they have won the trophy, right? Maybe 5 times, 3 times, and then 1 for others, right? Now this is one way of showing the data, which is a tabular way of showing the data. I could have shown the data using a pie chart as well. Possible? Let's say how many seasons have happened till date? 18. Now, if 18 is 100% for me, right? I can find out what 5 is. 5 divided by 18 multiplied by 100 will give me the percentage. Yes or no? Right? I can find out what is 3 for me. So 3 divided by 18 and all. So I'll get percentages. I can convert it into, I can find out of 360 how much will be the area that will be covered with 5, 3, 1, 1, 1, whatever. I can show it using a pie chart. Very well. I can show it using histograms, where I say that this is the frequency of how many times the team has won it. This is the name of the team. Right? Yes or no?
Yes.
I'm writing this, so they have won it 5, 5 and 3 times. Other teams have won it 1 time only. RCB has won it 1 time. Deccan Chargers has won it 1 time. Rajasthan Royals has won it 1 time. And who else? GT has won it 1 time. Right? So others have won it 1 time. But then these are different ways of showing the same data. Different ways of showing the same data. This is very basic. All of you understand this. Now, when I say that these are the different ways of showing the data, what am I saying here is, I am mostly just talking about the descriptives of the data. Right? So this is nothing but descriptive statistic, which is one branch or one leg of statistics, where you are just putting the data in a pictorial, graphical, tabular manner. Right? You're showing the data in a pictorial, graphical, tabular manner. You're just summarizing the data, telling us what this is. Number of males and females in a group, number of people with this income group, that income group. You're doing nothing. You're just summarizing the data and telling me that this is what you have, boss. Another thing is where predictive will come to, but then another thing is where I infer things. Infer. How do I infer things? Let's say this coffee seller says that in each glass, I'll not drink it. in each glass, I put 150 ml of coffee. That's what this person is saying. On an average. What are you saying? On an average. Okay, let me not write this. He's just saying that on an average, I put 150 ml of cool drink in this glass. Now you want to see whether this is correct or not, and you want to infer something from here, where you are trying to infer, let's say, whether the claim is right or wrong. I want to find out whether this claim is right or wrong. What do? I'll say, okay, whatever coffee is making on a specific day, I'll go and measure every time how much are you giving to the people, right? So let's say he has sold 100 coffees, 1, 2, 3, 4 till 100. First time there was 151 ml, second time there was 149, 150, 160, 130 and so on. Right? What he said was, on an average, there's 150 ml of coffee in my glass. On an average. These are all okay. Not a problem. But the average. So if I take them all, add them, if I sum them all, summation of all these terms divided by, if there are 100 people, should be is equals to 150 or more. That's what we are saying. You're trying to infer something. Inferential statistic. Descriptive statistic. We get into details of all this. I don't have to worry about anything. I'm just introducing who all are there in the family. So you have descriptive statistics, you have inferential statistics, and then you have predictive statistics, where a company says that I have been spending on advertisement and I get sales. You started a new business where you say that, okay, I've spent some money on advertisement and I get sales. So there are two things. Spending on advertisement, spending. And then you have sales. Now, the company says, when I spent 2 million, my sales was 4. When I spent 3 million, my sale was 5. When I spent 5 million, my sale was 9, and so on, let's say. Now, they are asking you a question. This year, I plan to have a budget of 9 million. What will be my sale? Predicting what is going to happen if you do this. Predictive statistics. 3 legs are clear. Descriptive is summarizing the data. Descriptive is summarizing the data. Inferential is when you are trying to infer something. Predictive is when you are trying to predict something. These 3 other things that we have. Now, we'll start with descriptive. We'll finish descriptive today. And then we'll move on to the inferential part, and then we'll move on to the predictive part. In descriptive statistics, we'll be looking at some pictorial ways of showing the data, graphical methods, this and all simple, interesting things. things that will make you like me. Right. And then statistics professor is cute. He's doing such small things and calling the subject difficult. Once you start liking me, I'll start talking about hypothesis testing, Z test, T test, ANOVA, and all. Then you'll go back and tell people yesterday you were thinking like you. Today you are problem is with you only. And then at the end, we'll talk about predictive statistics. But then we'll not be doing any of this on board or by hands. We'll be using Excel. Now, when I say Excel, all of you have your laptops with you?
Yes.
Before we even get to what statistics is and what all do we have in statistics and all. So this is what we just discussed, right? Descriptive statistics, inferential statistics. We'll come back to this, but I want you all to open Excel. See, why are we using Excel? We are using Excel because you can use whatever software or tool. You remember that story? There was a man and there was a big ship. So there was a problem on the ship. They tried everything, nothing worked. Then they called a man who was like, "I'll make it fine." And then he just went to a certain place on the ship, and then he just hit the ship with the hammer, and the ship started. All of you have heard this story, right? You know what happened afterwards? So he gave them a bill. They were like, "Why are you asking for this much and all?" And he said, "Because it's not about just the hit. It is about where to hit." उसके बाद क्या हुआ था? After that, something again happened. And then these people were like, this is a made up story, okay? This again happened. And then these people were again, they wanted somebody to help them. So they called another person. Now this time they did not call the same person because he would have charged 1 million for just one hit. So they called somebody who came in with all his fancy tools, not the hammer. So he had the chainsaw, this, that, all the electronic gadgets and all. And he kept trying, nothing happened. Right? Then they called this person again, the previous one. And he said that it is not about the tool. It is about knowing where to head. So it is not about the tool. Okay, so we'll be using Excel. We can use whatnot. We can use Movie, we can use SPSS, Minitab, R, Python. But then when things can be done easily on Excel, why can't we? And why don't we, right? So for this, what you'll have to do is, you'll have to get a plugin, simple plugin. For those of you who are using Mac, right, you will have this option in the data tab for plugins.
We can use
You can,
we can use sheets.
I don't know whether it works on Sheets or not. You'll need to have Excel. Right. For those of you who are online and are using Windows, I'll show it first. Go to File. In File, you will have options. Oh, wow. Can I plug in my laptop?
No.
I just have to change this, right? So you are getting this option in options here. If it is a genuine copy, I'm not saying ours is not genuine. Huh? This is genuine.
नहीं है भाई कहाँ से भाई YouTube एंड्रॉइड का चीज बहुत अच्छा ढूंढना पड़ेगा
Analysis toolkit.
back first first वाला inactive without EB वाला
ये वाला भी है.
दो है EB वाला नहीं without normal वाला EB वाला है
So you go to options, there you have plugins, there you go to add-ons, right? And then there you'll find analysis toolpack. Click on analysis toolpack, click on OK. Just get the analysis toolpack. Need not get the solver add-in, right? Or the VBA thing. Just the analysis toolpack. Hit the analysis toolpack, put it in your laptop. When you do it, you will see a new option popping up in the data tab. I'll show it. Why do we need this? Because this helps us do all the analysis just by click of one button. So you won't have to put your head in. Even if you're using AI, I am happy. If you're using ChatGPT to do the analysis, I don't have any problem.
मतलब I've noticed it's incorrect most of the times calculation incorrect
Okay, let's do one thing. Let's do one thing. Right. The world is full of surprises. I have a surprise. All of you have gone through the course outline. Did you go through the course outline?
That course specifically.
Wonderful. So if you've not gone through the course outline, in the course outline there is a assessment section. And the first assessment is quiz, which is surprise quiz. It is written there. So we'll have a quiz now. So this is your first surprise quiz in MU. So welcome to the world.
Already started meeting.
So we'll start with the quiz first. There are 15 questions in the quiz. All you have is 20 minutes, 15 minutes. How much time are we giving? 15 minutes? 15 minutes. So the idea is to just see how well are you guys aware of things. Simple, very simple things in statistics. It will give me also an idea that don't be worried. There are 3 quizzes, 3 surprise quizzes. I'll take best 2 out of 3. Right. So even if you don't do well in this one, and if you study well, you will be able to. But then surprises are surprises. It is very much possible that I might do the next quiz in the next class. And I can get over with all the quizzes in the right.
As you'll be able to see it on LMS.
Log into your LMS and start attempting the quiz. People who are online also, please go to the LMS and you will find the quiz there.
So where on LMS?
Activated. To-do list.
At LMS, you have a to-do list. Go to the to-do list, you will have it there.
So I've already clicked on okay.
Right side.
Start on the right, get started. Review.
Time is 2:05 right now. We'll finish it by 2:25 or 2:30 max.
Do we need a pen and paper calculation?
Hey, you don't have calculation. Follow the same.
Definition time.
Just very basic understanding. Don't use internet.
Sir, can't find it on LMS.
Right side with attendance.
To-do list. It's on the to-do list.
Check your to-do list. You'll find it on the to-do list.
You will get a notification also.
Anybody in the class has got it? Do you got it?
Yeah.
You don't need internet. You don't need anything. Don't be worried about the marks. Just be honest and do it. Right? If you score really well, I am telling you, your life will be fun. If you don't score well, your life will be easy. So it's okay. You do your best, but don't cheat. You're attempting it all. You're also attempting it. That's it, nicely. Easy, right?
अरे भाई साहब, टाइम हो गया सब ठीक है. Square. Sum of square. 769 minus 1.
पेपर चल रहा है पेपर चल रहा था
Burrito चाट यार मैंने भी अभी देखा यस
Guys,
करना पड़ेगा स्टार्ट
Still 10 minutes.
20 minutes. 20 minutes.
नहीं
Not the fourth question to watch is
अनोवा टेबल देख के याद आ गया दिखाया था
that was regression output.
mean of square variance p value t value सब यार
There's no negative marking, huh? Make sure that they know it.
एक सीएसए में क्या पूरा सीएसए कॉस्ट लेवल में किया था
ये भी नहीं था
जाएगा
Right? You submitted?
No, I'm just understanding the term कि क्या है
Wow.
What's the question?
You don't understand the terms opening internet, huh? That's wrong.
Because the calling is not a matter.
Not even ChatGPT. You have submitted. So you're not using that. Submit it.
Going to be very honest, I don't laptop. Okay. You will no.
Yeah.
Last 5 minutes.
So, any idea? Excel. Large Excel.
That's it, Excel.
Have Microsoft Office. So, rather than purchasing for 8,000.
Fine.
Everyone required. It's everybody meeting.
I don't indulge in anything that is unethical.
In 365 year. My family was there. One 40.
Save Excel करना है? First time. 689.
I still want to do. Officially content.
Last 3 minutes. Guys, start submitting if you've done. Actually. People who are online, are you done? Those of you who are done, it's okay. I hope everybody was able to start. Right. Wonderful.
पे करना छोड़ोगे तो तुम
2 more minutes.
याद आ रही थी
Yeah, like
Twenty people have submitted.
ChatGPT चल रहा होगा परफॉर्मेंस स्टैटिस्टिकली कंपेयर करना ऑनलाइन
We can actually do that. We'll do that. Remind me. When we reach to t-test, hypothesis testing, we'll do it. Null hypothesis will be that both are equal.
उसके अंदर क्वांटिटेटिव मेथड्स टेक्निकल इसके अंदर
और क्या मुझे लगा
Hypothesis testing.
वाला होता था
क्या नहीं है
वो जो एक टेबल दूसरा होता है उसमें से ढूंढो 95% फिर आपसे ज्यादा है कम है कंपेयर करो
रिजल्ट का
तो कुछ
कैसे
ऐसे
पता चलेगा कितना घटिया क्या
जब सबने फिल कर दिया
नहीं वो
Sir, has my quiz been submitted? It just says start quiz again.
What's your name?
Puneet, sir.
I'll let you know whether we've got it or not.
Sure.
निकालने का वापस नहीं आ गया
टी-शर्ट्स की बाइंग
थोड़ी देर में बताएंगे
Everybody in the class has done it. Time is up. Even if you have not completed it, just press on submit. Last and submit. Because we get a timestamp also. Whoever submits after 221 will not get marks. So,
स्टार्टिंग में
this is marks. Why are you worried about marks? Marks and all is. Time to now, leave all that and start thinking about numbers and other senses. Right. There comes okay, guys. Get back to the class. Everybody is submitted inside the class, right? Yes. Done, everyone? Wonderful. People who are online, please submit. For those of you who have doubts whether it got submitted or not, we'll let you know. Now, what I was just saying was that there comes a time in your life when you start, thinking about numbers in different ways. So when you guys were in your school, UG programs, you would have been thinking about numbers as in marks and all. Now you don't think about तेरे कितने आए का मतलब वो नहीं है मार्क्स कितने आए महीने कितने आए करते हैं क्या पिछली बार कम घटा हुआ टैक्स so that's how it happened. Okay, now come back. See, the idea of the quiz was not to judge your level of understanding or anything because we have not learned anything. But it was just for me to understand where are we. So I'll also get a sense that on what level do I have to go and do things. So we have not done anything. The quiz was very, very basic, right? Very, very basic in terms of if there was somebody who did not even understand what a symmetric curve is, mean is equals to median or not, what are mutually exclusive events, if you don't know about probability, then I'll be careful I'll keep those people in mind and I'll be going in detail for those things as well. But if everybody in the class does really well, and if everybody has got 20 or 15 on 15, then I'll know that I can go on and talk about much advanced stuff. Right? So this is what the idea was behind this quiz. And another thing is I got one thing off my head. I had to do 3 quizzes, so one is already done. I am also happy. Right? Okay, but then we'll take 2 best out of 3. So if you have not done well, also need not be worried. Also, if there is someone who is absent, so you can be absent on one of the 3 days. If you are absent on 2 days or all the 3 days when the quiz happened, so I'll see. Right. Anyways, we have only 5 sessions. So, okay. Now, till this point, we have talked about statistics, data variable. We have talked about descriptive statistics, inferential statistics, and predictive statistics. I hope everybody is clear about this. Now we'll go in the depth of descriptive statistics. When I talk, and I'll just show you some names on the board, right? You need to tell me whether you've heard about these, know about these, have seen these ever or not. Right? If you have seen these, my job gets a little easy and we can focus on other things. Have you heard about frequency distribution?
Yes.
Have you heard about bar graphs?
Yes.
Pie charts?
Yes.
Yes.
Have you heard about histograms?
Yes.
Scatter diagrams?
Yes.
Yes.
No.
No.
Again, frequency distributions?
Yes.
Yes.
Bar graphs?
Yes.
Scatter diagram?
Yes.
Ah.
Array XY scatter plot.
Now, dot plot, Aujai and scatter plot. These 3 you might have not, I did not even ask about dot plot and Aujai. We'll hold this. Dot plot, Aujai and scatter we'll hold. Let's start from here. Mean, median and mode.
Yes.
Yes.
Everybody knows what mean, median and mode is?
Yes.
No? Did I hear a yes or a no?
Yes. Sir. We know.
Okay. You've heard about percentile, quartile?
Yes.
Percentile everybody knows?
Percentile, decile.
Quartile is what? Q1,
25.
Q2, Q3, 25th, 15th and
75. 100.
range?
5 minus 2.
Range? Variance? Standard deviation?
Yes.
Standard deviation, it's not variance, it's deviation. Distribution shape. Now we'll talk about distribution shape, don't
Normal
worry.
distribution.
It need not be only one, different distributions are different shapes. Box plot and outliers. Now, we'll discuss all this through examples. If you've not heard also, it's good. If you've heard, very good. Right. We'll very quickly discuss all these, and in the slides that is there on LMS already. I think the slide is there on LMS already. If it is, don't need to check right now. It's okay. Don't check. If it is not there, you'll get it by today. The slide deck that we have shared with you, it's a huge slide deck. It's some 330, 40 slides. Everything is there on the slides in detail for you to refer to go through and to, so even if you go through the slides, you'll understand everything. But today, the idea is to learn all this in this specific class, right? Now, if you see that these are the numerical measures for descriptive statistics, and these are pictorial and graphical methods. These are just the charts and these are just the numbers. Now, let us discuss some cases, right? Let's talk about a very famous food delivery app. What is that?
Zomato.
Swiggy or Zomato? Zomato. How many of you have watched the movie? Zomato. Only one. Right, tu khali aur main khali. Right. So let's say any famous online platform which claims that we deliver food. There's a movie. Kapil Sharma's. Right.
It sounds funny.
Yeah. So, where were we? So, So, let's say if they make a claim that we deliver food in 30 minutes, right? On an average, we take 30 minutes to deliver you food. Now, everything is good. They make, let's say, 100 orders. In those 100 orders, they deliver 98 orders in 20 minutes, right? If this had to be 30 minutes an average, if the average had to be 30 minutes for 100 orders, what would have been the total sum? 30 into 100,
30,000. 8,000.
which is 3 and 3 zeros. 30,000.
3,000.
Okay. So 3,000. In this case, okay, it's okay. In this case, how much have you got already?
1960.
1960.
Right? So that means the two orders that are remaining,
104.
you have spent how much time
040.
for these two orders? So average is coming out to be somewhere around 520 minutes. Yes or no? 520 minutes, which is how many hours?
8 hours, 40 minutes.
8 hours and
40 minutes.
40 minutes. Now, this is not acceptable for a delivery app as good as right? You order lunch, you got dinner. Right? So, the point that I'm trying to make here is if somebody makes a claim that we deliver food in this much time, that claim might be a very, very misleading claim as well. We have just seen it, right? Now you think that this is good, I'll go ahead with this, and you end up having your lunch and dinner. Let's say there's another app. Which app would you want to talk about? Let's say any app. Any app. Uber. They say that you get a cab within this much time, but the same thing happens. The rest of the things are little early, and then there is one or two cases which extend beyond a particular thing. Now, why is this a problem? Why is this a problem? Somebody might say, "Arey, 98% of the time they're able to deliver on time. In fact, before time." What is the problem? The problem is variability. The problem is variability. I, as a customer, would want my app or the delivery partner to be highly reliable. When I say highly reliable, what do I mean? I would want the food to be delivered in that specific time which the company is claiming. Right? I want the 30 minutes to be the upper limit. If it goes beyond that, the company will lose me. And if they're losing 2% of the customers just like that, I did not talk about the customer retention and customer acquisition cost. Right? So I will start incurring losses and very soon I'll be out of business. I'll give you another example. Let's say all of you, you get a job offer. Right? Let's say you don't get a job offer. You want to join, let's say there's a HR firm that comes to you and says that you enroll with us, we'll give you some training and all. And after that, you'll get a job offer. And our job offers have been, we have an average of 45 lakhs per candidate is our average. Right? Now, you did not think of anything, you joined them. And what you found out was that out of these 45 lakh average that they were saying, there were only 4 people that got placed out of whatever number they had. And one was the CEO of the company who's withdrawing, let's say, 2 CR. Is it possible? No. There is the CEO of the company who's withdrawing, let's say, some 1 CR. Right? And the rest 3 people, if it has to be 45 lakhs, how much will be the total? 1.8. And the rest 3 people have got
70 lakhs.
80 lakh, which is around 26, 27 lakhs per person. Again, a claim that is true in all sense. They are not lying. But then you got fooled because you did not go in depth. What do you observe in these 2 cases? First case is that there are outliers because of which the entire problem is there and my mean gets heavily shifted. The other one is that the numbers are very, very less. Only 4 people. So N or the sample size that we're talking about is very, very less. That is why I say that mean is not a very reliable and a very good metrics to look at. Right? So if mean is not a very good metric to look at, what else do we have?
Mode and median.
We have mode and median. Right? So here, there are 3 things mentioned, mean, median and mode. Now, think of it as a Bollywood movie. Right? There's a Bollywood movie. In the Bollywood movie, because mean is something that we hear the most. Mean, whatever book you will follow, whatever hypothesis testing you do, you have hypothesis testing primarily for mean and then you have things for median as well. But the mean is something that is talked about very, very, very frequently. So who gets talked about the most in a Bollywood movie? The hero, right? So mean is the hero of this movie. Now, this hero will have a villain also in the movie, right? The villain is, who's the villain? What happened here? Because of an outlier, things got stretched outside, right? So the villain or the problematic thing for mean is outliers. Because of outliers, what happens is that the variability in the data goes up. Variability in the data goes up. You all have heard about this name, Karun Nair?
Yes.
How many of you have not heard his name? You guys have a lot of good things to do in life. Other people are waiting. Good. You have not heard his name. No, he's a cricketer. He's represented India in Test cricket. Respected personality, I'm sorry. But in the first match, he scored a triple century, 300, and then he had a series of zeros. Now, when a player scores 300 and then 0, 0, 0, 10, 12, 8, 4, 5, 6, what sense can you make? What is his true capability? What is he capable of? Is he a player who's first match you score a 300 and everybody's doing gaga and like, oh, we have got a next Sehwag and this and that and all. But the next match 0, okay, happens sometimes, happens in the best. 0, 3, 5, 8, 2, 0, 5, 6. And then he got out of the team. He recently came back, but in that series also he could score only 150, otherwise a lot of failures. Now, when somebody scores a 300 and 0 in the next match, what is the average?
150.
150. Too high average for it. Don Bradman could not 100. And this guy is at 150. Like saying I am the king of cricket. Let's say third match, 0 again. Average still 50. 150, 0, 0.
तो 100 होगा
मैं ये काम करता हूँ ये मेरी नौकरी oh sorry 150 नहीं था 300 good that you guys are attentive so you scored 300 and then 0 and 0 your average becomes 100 300 150 100 average is dropping massively right when you are scoring on extreme these are extremes so my average is villain is outliers, extremes. My mean will not like outliers. My mean will shift madly if there is an outlier in the data. Let's talk about the mean age of this class. Mean age. 24. अरे मैडम बताना, I'm not asking. आपसे तो बिल्कुल नहीं लड़के से पूछती नहीं मम्मी ने बताया था. I just randomly 24, 25, 27. Let's say there'll be somebody who might be 32 also in the class. Might be somebody who is 18 also in the class. Somebody who's sitting might be 35, 36. Somebody who's standing might be 18. Right? Now, because of these people still, you're not going on extremes. You're remaining in a range. Let's say some 20 to 25. 20, 25, 26. The mean will be somewhere in between these numbers only. Now, let's say one of you gets the elixir. वो क्या अमृत? And is now, will never ever die. And what will be the age? Infinite? Infinite? Let's say that person has been there for 2000 years. Right? The age is 2000 years, let's say. Because of that one person, you guys are like saying 20, 25, 21, 24, whatever. And then here comes the boss. Where will the mean go? Mean will be very, very high. Then somebody will come and say, this is a class of olds. All the oldies are sitting here because the mean is very, very high. You're getting how outlier affects right? The entire thing. So outlier is bad. Very, very bad. The villain of the movie. Because of this outlier, there is a statistic that we use, which is known as standard deviation. What is standard deviation? No formula, I promise. But standard deviation is a measure which tells you how your numbers are spread around the mean. So let's say I take out the mean. In this case, let's say mean comes out to be what? I don't even care about this. There are 5 numbers. 2000 divided by 5.
400.
So mean will be somewhere around 400.
418.
Let's say, okay, बहुत बदल गया भाई. बोर्ड भी मना कर रहा है नहीं. 418 you said, right? Okay. Now your mean is 418. Now, standard deviation will be calculated as the distance of all the numbers from this. So distance of this from this, this to this, this to this, this to this, and this to this. ये भाई तो ना घर का हुआ ना घाट का. He is neither towards 2000 nor towards 20s. So he is somewhere in between and has no friends around him because the numbers are spread like this. There are 4-5 numbers together in this range, and then there's a number here, and your mean is lying somewhere here. Right? There's no one around him, feeling lonely, bad. Standard deviation. How your data is spread around. You have 2 cricketers. I'll keep coming back to cricket. I'll tell you why. Because I'm writing a book on understanding statistics through international cricket. I have a lot of examples to talk about these days. So one example is Rahul Dravid and Virendra Sehwag. Both are great batsmen that the country has produced. Whom do we call as Mr. Dependable? Why? Less deviation. Consistency. He was a consistent batsman. Very difficult to get him out on zero. Sehwag will either go boom boom or will be sitting in the dressing room having his samosas and pakoras. So that's why if you talk about consistency, you talk about Rahul Dravid. And if you look at the standard deviation, whose standard deviation you think will be low? Rahul Dravid's standard deviation will be low because he's consistent. So if you look at the spread of their scores, their runs, Virendra Sehwag has scored 319 or 29? 19. 319, Multan? And obviously 0. Dravid also would have scored 0, but here it is 278, I think. I don't know. And then most of the things will be around the mean. For him it will be spread. Are you getting what I'm trying to say? So standard deviation will be high when the data is spread. I don't want my data to be spread a lot. My enemy is standard deviation. Why is standard deviation high? Because the data is spread. Who becomes a villain in this case? Outlier. Because one outlier can ruin the entire thing. Right? Are we all good? Right? Now, who comes to the rescue? Who is the sidekick? Who is the hero's friend? Who will come to the rescue of the hero? Who will save mean? Median will save the mean. How? Median says that I don't care. I don't care about who's on the extreme. You kill this, kill this, kill this, kill this. You are in the middle. I'll stick with you. Whosoever is standing in the middle is the median. The middle value is the median. Now things are easy. Why? See, in this case, median is telling me that the median age of the class is 25. I know that there are 50% values above this, 50% of the values are below this. This is the middle, right? If I have both these statistics, now I can make better sense of things. Median is 25, mean is 418. What does that mean? That clearly means that there is a very, 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 very big number towards the higher end. Right? Kill that, remove that. I don't like that. Also, when I tell you this, this is getting boring. No. All of you are liking, enjoying, having fun, watching the movie. Right? No, I ask this because I want to introduce a new concept here, which I don't introduce here generally. I keep it for the end. But then because the mood is set, we can. Skewness. Right, skewed. Skewness. Right, skewed. Now in this case, see what has happened. There was one outlier here. 2000. Here. The other kids are playing in this area. 20, 21, and so on. right? The average, now what does my distribution look like? The frequency will be high between 20 to 30. Frequency here will be very, very low. Right? If I want to, and if I take more data from more students, I'll have more people coming here, right? There'll be more and more people in this range, only 20 to 30 is where everybody is. My distribution should look like this. Yes or no?
Yes.
This is what the frequency is. The hump is where the frequency is high. The tail is longer because you have a value on the extreme, right? We'll talk about it in detail. I told you that I don't introduce it here, but then the mood was set, that's fine. Where is the mean? 418. So you want 20 to 30 here. You have 2000 there, so mean will be somewhere here. Mean. And the median is where? Here, 25. Median. What do you see? Mean is higher than the median. Mean is greater than the median. That means there's an outlier on the higher side. Logically also, the way you've seen the tug of wars,
Yes.
right? If there's one heavyweight person standing on one end, and there are all the other, thin people standing on the other end, irrespective of whether these people are higher in number. Let's say there are 20 people here, but then this giant is one person who's standing here with 4 of his friends. He'll pull them all. What is happening? That's exactly what is happening. This giant is pulling them towards this side. So the mean is getting shifted towards this side. So the mean is higher than the median. This kind of situation in a normal data is known as right skewed data. Right skewed. The data is skewed towards right. Getting stretched, skewed towards right. It is also known as a positively skewed data. If positive or right. If the case would have been different, if the case would have been on this side, right? Everybody in the class is 25, 26, 25, 26, but then there is a seriously super intelligent kid who has got admission when he is only 5 years. Right? The data will be shifted towards this side. Now that person will be an outlier. 5 years, all of you are here. 25 to 30. This is where your median is. 20 to 30, let's say. Median is at 25. But because of this kid who is 5 years old, the mean will be shifted here. Right? So the mean in this case will be lower than the median. The mean is lower than the median. The data is getting stretched on the left side. So this is negative or left skewed data. We'll come back to this again. Right? You don't have to worry a lot if you're not. If you're getting this or not?
Yes.
Bouncer तो नहीं था?
पूरा नहीं
हाँ?
पूरा नहीं
पूरा नहीं था, थोड़ा सा था. किधर दिक्कत आया?
दिक्कत नहीं है बस understanding.
That is fine. That is enough. Now one thing is clear. All of yes, sir.
Basis has to be some chronology or something for left or right to be be defined, or else it's just
No. There is. You have seen the graph papers generally. In schools, we used to. So the origin used to be at 0, 0 here. Then we used to increase x on this side and y on this side. That is why we are seeing when the numbers are large, larger numbers will be on this side. Right? So the larger the numbers are, so because this is how it is. So smaller numbers are here. So if you have the tail stretch on this side, tail is longer on the smaller side. Mean will be here. Median will be here. So mean is smaller than median. The tail is longer on the left side. That's why we call it left and right. That's it. Because remember it always in statistics, whenever I'll be making a diagram, whenever you'll be making a diagram, the numbers get large from left to right. You increase from left to right. That's how. Now, mean median mode, the Bollywood story is clear. Mean is the hero. You use it multiple times, but then mean alone is difficult sometimes. In order to make mean's life better, what will you do? Kill the villain. Now, killing the villain means killing the outliers. I told you who the villain is. Villain is the outliers. As soon as you kill the outliers, as soon as you kill the villain, other things fall in place. The standard deviation will come down. And if I remove this, what will happen?
2000.
Zoom in over.
Whatever.
बहुत ज़्यादा zoom in होंगे.
सर वो बोला ना माइनस प्लस का साइन ये सब
That is to add pages.
That is to add.
It's okay. I don't need it. I'm a very adjusting nature sort of person. Things that go beyond my control, I just. Okay. So if I remove this 2,000, whatever I did comes on the board automatically. So if I remove this 2,000, my mean will come, let's say somewhere around 22. From 400 it has come to 22 now. Things have become good in life. Kill the outliers. That's why we don't need outliers in the data. But for that, you have to identify the outliers first of all. So we need a rule for identifying the outliers. Right? One simple thumb rule is anything which is 4 standard deviations away from the mean. But standard deviation in itself dependent on, right? On outliers is touched by outliers, gets stressed because of outliers, so that becomes a problematic thing. But then still, you are able to, we'll do cases and we'll do it on Excel and we'll find out that it helps. Right? There are numerous ways in which you can identify outliers by graphical methods also. The most famous diagram or the most famous statistics to understand outliers is your box plot. Box plot. You can write in front of box plot. Generally used to identify outliers. Box plot is a very interesting diagram. I'll show it to you. We'll look at all. Now, mean, median, mode story. Mean and median story is clear. Mode.
Sir, I just have a question. What if there's not one outlier?
Oh, yes.
But many. So, like, how do I choose which outlier?
Wonderful. And this question is very, very important. Let's say that you have something which is, let's say we're talking about income data. Income, right? Let's say I ask everybody's family income. Most of you are saying that the family income is, let's say, 20 lakhs, 18 lakhs, 19 lakhs, 24 lakhs, 36 lakhs, 50 lakhs. Somebody saying 12 lakhs, 18 lakhs, whatever. But then there's one person who says that my family income or my family's income is minus 50 lakhs. Possible?
You're spending more than what you're.
Somebody says that my family income is 150 lakhs. Possible?
Yes.
These are both outliers according to me. Because I am playing in the range of 12 to 36 or 50. Then comes suddenly which is minus 50 and now what? In his question there lies another question. So these two outliers will cancel each other. अगर आपने ये और ये मान लो कि ये 100 ही होता तो minus 50 और 100 50 रह गया सिर्फ तो ये तो कैंसिल आउट हो गया आपको कैसे पता चलेगा कि इसकी वजह से मेरा मीन इधर उधर जा रहा है या नहीं जा रहा है how will I find out whether so now there are two outliers, two villains. The villains are also enemies of each other. They kill each other. Hero is saying I am safe. Is the hero safe? No. Why? Because of their war, the hero will still be unstable. Right? How do we identify that and how do we say that these are outliers? That's where I say box plot is important. What does box plot look like? This is what a box plot looks like generally. What do you have on this? You have the lowest number here. Again, the logic remains the same. Increasing on this side. Lowest, highest. Highest minus lowest will give you what? Range. Highest minus lowest will give you range. Your range is also sensitive to outliers. You will accept that. क्योंकि highest और lowest में तो range तो sensitive है. Outlier हटाओगे तो range बहुत कम हो जाएगा. Range is sensitive to outlier. This is your quartile 1. This is your quartile 2 or median. And this is your quartile 3. Now you tell me, when I do this, if the data has no outliers, it should look like this. But what if it starts looking like this? What if it starts looking like
लोड हो रहा है
लोड हो रहा है? Perfect.
बीच में से still it's
Suffering आ रहा है सर
center
But what if I say, so okay, मैं कुछ नहीं बचता तो मैं scarecrow बन जाता हूँ. So this is the low end. चलो ऐसे देख लो. इनको देखो तो ये मान. This is the high end. This is the low end. From here starts quartile 1. This is median. This is quartile 2. Now if I say that it is looking like this, what does it mean?
Left skewed.
This is way higher on this side. There is no outlier on this side. So there is a outlier here. Because of this, what will happen? My mean will be shifted towards this side, which means that the data is right skewed. Sorry, left skewed. ये आदत वाली हुई है ना ऐसे. So the data is left skewed. If it is like this, the data is right skewed. This is one way of identifying outliers. Another way of identifying outliers mathematically is you do tests for outliers. And the data will tell you that there are outliers or not. The test will tell you that there are 5 outliers in this data. This, and this. Kill them. Remove them. Right? That is the easiest way of doing it. If you have outliers on both the ends, what will happen? You'll have a diagram with this very small, but the whiskers expanding to a large this thing. So these are whiskers, okay? Box and whiskers. Box and whiskers. Right? Now, mean median is good. Mean median is understood. What is this mode doing here? Mode is like most ignored statistic in this world, I am telling you. And you'll see in our class also, we'll talk about it today. Today I'll tell you it is very important. Because I have to teach you. But then after this, you will never see me using mode. Right? But then it is important. People who remember mode actually sometimes outclass other people, other statisticians who don't remember mode. Mode is a versatile player. Mode is a friend who can gel well with categorical data also. And we need to discuss about data also. Okay. Mode is something. So let's say if I talk about names, here I don't see any 2 people with the same name. Right? No statistic. Mean. Can I apply mean on names? I can talk about maybe the number of letters that are there in each name, but then names and means don't go well. For mean, I need some quantitative number. Right? Quantitative data. For median as well. Median I can still say that okay, find something which is in the middle, this and that and all. Mode is something that talks about both. बेटा आप अकेले नहीं खा पाओ टीवी नहीं खाओ खुली हुई है बंद है खुली होती तो मैं पहले सूंघता हूँ फिर मैं पीने देता हूँ. Right. So we're talking about mode. Now mode is something which can be used on categorical, qualitative, quantitative data. If I have 5 R's sitting in this class, I can say there are 5 R's in the class, right? If I have 5 Kaushal in the class, opening, Kaushal is opening. Yes, Kaushal is opening. 5 Kaushal sitting in the class, opening their can of Red Bull. I'll say that there are 5. So mode becomes 5. The number that is getting repeated the most. Logically speaking, you tell me what should happen if I have a symmetrical data. If the data is symmetrical, which means no outliers, things are very well established. My mode, median, and mean should all be equal. Coinciding should all be equal. When I was doing PhD, I had a colleague who is still a friend. He used to put a tika. Nothing against, I'm not speaking against any religion, disclaimer. It's about a friend of mine. So he used to have a tika. And then he used to put this tika and then put a curve also. So I used to tell him, you wear mean median mode on your head. It's a perfectly symmetrical. How do you? Right? So that's how I remember. They all should be there. If it is a symmetrical data, if the data is right skewed, you know what will happen. Mean will be shifting towards higher side. Left skewed, you know what will be happening. Also, right skewed and left skewed can be a property because of mode also. Now, mode does not sit in the middle. Mode says, no, I am going towards the positive side and sits here. Mind it, what does mode mean? The number that is getting repeated the most. The number that is getting repeated the most will have higher frequency, will have a higher weight now in the mean. And the mean will shift towards mode. Mode can disrupt things. Mode is the powerful politician in the movie who is generally ignored in most of the movies, but if he's there, he might do what not. All of you have seen Dhurandhar. You know what? Right? तुम्हें अच्छा है. Mode is saying तुम्हें मेरा अच्छा है. आ जा इधर. Hold the mean close to. So that's how mean, median, and mode behave. Now, with mean, median, and mode, we have also talked about standard deviation. All of you know what standard deviation is. Standard deviation is talking about the distance. Variance is square of standard deviation. Now, you know where to use mean, median, and mode. Can we also, so if you have standard deviation already in the picture, the movie has standard deviation already existing. Why do we need variance then? So the way we calculate, the answer lies in the formula. I'll not tell you about the formula, but the formula, when you calculate this thing, you calculate variance first and then you take under root of variance and then you call it. So we have variance first. मुर्गी पहले आई अंडा. तो अब भाई अब मुर्गी अगर पहले आ गई मान लो. Let us assume that the hen came first. If the hen came first, then why? Because of the hen, you will have the egg. Right? Because of the hen, you will have the egg, and that's how it will. So because variance came first, right? The formula is for variance. We get variance. But we don't like variance. Why? Because variance is a squared term.
Percentage square.
So if I am saying that my age or my income is this, and I say that the variance is, let's say, 64, you'll be like, what? How do I make sense out of this? What is the distance of mean from these numbers? How do I know? But then I say, no. I will give you a better statistic known as standard deviation, which is square root of this, which is 8. Now you say, okay, this is in the same unit. Now you're telling me that the numbers are varying by 8 million in this class. So if the standard deviation of income is 8 in this class, is let's say 12 in some other class, you can then tell me, oh, this class is more consistent in terms of income in comparison to other class where the standard deviation is higher. Higher standard deviation means the data is spread. Lower means the data. So this will give you a better idea. That is why you have square of variance, which is known as standard deviation. If you want to look at formula, I can show you the formula.
Sigma x minus x bar whole square divided by
So every number that you have, you subtract mean from that, square that and keep adding it for all the numbers. And then you divide it by,
minus 1.
So this is how you find mean. Mean is summation of all the numbers divided by n. Then you have, so we are showing how outliers actually play a role. In this case, if you'll see, the mean has shifted from, because there is 20 in the vicinity, the mean will be shifted towards the higher side, right? So mean is from 13, it has become 14, whereas the median is still remaining at 13. So outliers play a role in mean, but not median. Mode you all understand. Now, generally mean, median and mode, not generally. Mean, median and mode, they are known as together the central tendency of the data. Please write this somewhere. Mean, median and mode talk about the central tendency of the data. It talks about how the data is situated, where it is situated, how does it look like. Mean, median and mode together are they talk about central tendency of the data. Central tendency. Where is the data located? Now your range, your standard deviation, your variance, these are the measures of dispersion. Wonderful. Great. So central tendency is fine, mean, median and mode. Then you have dispersion, where you're talking about range, variance, standard deviation and coefficient of variation. Okay. You all know who this person?
Einstein.
His IQ level was very, very high. Yeah. So, but then these people are very, very less. Right? Such people are very, very less. That's why The curve that you're seeing is known as an asymptotic curve. I don't want you to remember this name. I know you will not. It took me 9 years to remember. Just kidding. पहली बार सुना और यार दिमाग तेज है कभी घमंड नहीं किया. So this is asymptotic curve. What is an asymptotic curve? Asymptotic curve is a curve which appears to meet the axis at infinity. कभी मिलेंगे नहीं पर लगेगा कि मिल रहे हैं. Right? This is like you having a relationship when your parents don't know about it. Right? And you feel that we are going to meet and you don't end up, the relationship gets in problems because of the parents. हमारे जमाने में ऐसा होता है. So you're talking about asymptotic curves which appear to meet at infinity but they never meet. Now why is it getting so thin? Why is the line getting so thin? Because the chances of any event here is very, very low. The probability is very, 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 very low. As you come in the middle, most of the people will be in this IQ range. That is why the chances are high. Similarly here, the chances will be low. Who are the people who are here? Don't know about you. All my siblings are here. On this side. Right? Because sometimes I get to teach them also. Then I tell them, who are here? Right? So that's how standard deviation talks about. Now, if this would have been random, right, you would have had more numbers here and more numbers here as well. That brings us to another concept.
Wow.
That brings us to another concept. One is this. Right? And I say that there's another curve which is like this, and there's another curve which is like this. What is happening?
Kurtosis, positive, negative.
The thickness
In
of
the
the tail.
first case, the tails are very, very thin. The tails are very, very thin. In the second one, the tails are becoming a little thicker. And the third one, the tails are very, very thick. If I extend this for some more time, what will happen? I'll have a curve which looks like this. Think of it like a balloon. You have a balloon filled with water. अभी होली गई थी सबने देखे होंगे. Now, if the balloon is like this, right? And right now, the balloon, if you press it from the sides, it'll get more and more elongated from the middle. That's what we are seeing on the board. Pressing it from the sides, getting elongated on the center. If you're pulling it on the sides, this will come down because the water inside the balloon is fixed. Water is fixed. The change in the shape will also result in the change in the center. Right? If you are stretching it more, it will become like this, and ultimately it will become like this. I wanted to write something. Area under any curve. Area under any curve is 1. Area under any curve will be 1. This is, we have proof for this in integration and all. We will not go there, but you remember this, that the area under any curve is 1. Whatever I am writing here, for the people who are online, are you able to see it?
Yes.
Are you able to see the mirror image of the things, or are you able to read it clearly?
Mirror image.
They have a screen share.
Mirror
There is a screen share also. Okay. Because I just saw a mirror image of what I was writing. So if I
screen share. Mirror image हो रहा है उधर.
we can see, okay, they're able to see. See, I thought there is mirror, but it's okay. The area is 1. Area is 1. I think the water inside the balloon is 1 liter. Water will not change. It will remain 1 liter. Only the shape will change. Now let's make practical sense out of this. Let's talk about what is happening. I'll give you a daily life layman's example first, and then we'll move to a business example. Okay, I said example. I am not able to read this. Let's say that this is rainfall data. Okay, rainfall data. Now, what is the average rainfall in this part of the country? Anyone? मेरे को कौन सा पता है?
300.
800 पानी में होते कब मारना है भाई
50 mm. 774.
when you do it in mm let's say it is 80 mm let's say
774.
774 mm
नहीं 8 5 सेंटीमीटर. हाँ दिल्ली की.
कुछ भी ले लो यार अरे और एग्जांपल
अरे हमारे क्या जा रहा है डूब जाएगी डूब आपको पढ़े ना
Centimeter.
now let's say the average rainfall is भाई ने बोला मेरे को लगा इंटरनेट पे देख के बोला 800 mm is the average rainfall. Average rainfall. Average rainfall. Okay. There'll be years. Now I have data for let's say last 100 years. I have data for last 100 years. There'll be years when the rain would have been let's say only 30, 40, 50. Let's say 50. 50 mm. Possible. The probability might be very, very less. Out of the 100 years, only 1 year had this. 60-70% of the years are ranging from let's say 750, 700 to 900. Mostly it is here. But there would have been 1 year where it would have been like flooded also, let's say somewhere around 1550, 1600 ml. Possible. Now, if you have something looking like this and you're talking about rainfall data, you will be happy. You should be happy. Why? Because you know the chance of drought and flood is low, is very low because the tails are thin. What if things become like this? Now you're telling me that 50, 1550, 800. You're saying that it used to be only once in 100 years, here or here. Now it has become 5 times, let's say here and here. Good or bad? Bad. The extremes are more. Either droughts or floods. Droughts, floods. Mostly it is here, but then 10 times in a year, in 100 years, that is once in 10 years, you are having either drought or flood. Right? Let's say it was 1. Now this has become 5. So that means 10 total out of 100. 1 in 10 years, you are having either drought or flood. Happy birthday to you. 50, 1550. हो गया. So 30. Rest 40 is here, let's say. Now 6 times out of 10, you are having droughts and floods. और तीसरे साल बाढ़ आ रही है और तीसरे साल सूखा पड़ रहा है. अब आप तैयारी नहीं कर पा रहे. और अगर ऐसा हो जाए, everything has equal probability. Government does not know what is going to happen. Government नालियां भी खोद रही है, जब सूखा पड़ रहा है तो उसमें पानी भी बाहर है. You'll have to, right? So this is the problem. This is the problem. And what is this known as? Kurtosis. Just like skewness.
Yes.
Kurtosis. There are 3 in skewness. You had positive and negative. Positive is also known as right. Negative is also known as left. Kurtosis has 3 things. When the tails are extremely thick. Okay. One is this. The other one is this. And the third one is third one is let's say
Dotted.
Lefty good.
this. When the peak is too high, leptokurtic. Right? Leptokurtic, leptikurtic, you can call it leptokurtic. Leptikurtic, whatever is leptikurtic, leptokurtic. When the peak is normal is mesokurtic. And when the tails are thick, peak is low, platykurtic. Platykurtic means a plateau sort of situation is getting formed. A plateau is getting formed, right? So platykurtic, mesokurtic, leptikurtic.
Are these relative definitions or there is a
That is very good. Thank you so much. I forgot completely. Thank you. When you do descriptive statistic, you get a measure. So if the kurtosis is in between -3 to +3, it is mesokurtic. Anything above +3 is leptokurtic. Anything below -3 is platykurtic. -3 to +3. In between is meso. On this side it will be platic. On this side it will be leptic. Sorry. Similarly, for right skewed and left skewed, one thing is clear. If skewness is negative, you'll call it left skewed. If the skewness metric is positive, you'll call it. But then see, when we say skewness, there's a difference. There is a case which looks like this, versus there's a case which looks like this. Both are skewed. This is highly skewed towards
Left.
this is little less skewed towards left. Both are negatively skewed. This is also negative and this is also. How do you tell which one is more? More the negative the term and all. There also we say if anything is more than -3, we say it is highly skewed. It is more than +3, we say it is highly skewed again. In between -3, +3, we say it is okay. If you want to be a little more strict, people have said +1 and -1 also. But +1, -1 is too much, right? Too much. We are getting very, very strict. So -3, +3 is the range there also. Thank you so much. I would have. This is what happens when you don't use slides. But that's why I have slides. I'll show you the play. Okay, so we have talked about kurtosis. We have talked about standard deviation. We have talked about range. We have talked about variance. Range, variance, standard deviation, all these things are fine. Are you all
ऑनलाइन ले रहे थे हम लोग अभी भी ऑनलाइन में ही है ऑनलाइन के
यहाँ
नहीं गया हाँ
ऑनलाइन ले रहे थे तो बात बताओ रूल क्या है क्लास का
क्लास का गुड मॉर्निंग
can I roast you or not?
Yeah, good. Sorry.
Go ahead. That's the rule of the class. I can crack jokes, you can crack jokes.
Oh, thanks.
Online ले नहीं रहा था ये. I don't know, you come too early for this class. This class they'll not get attendance for. Sure. ये दो भाई आए अभी हमारे. Okay. This is how statistics. इसके बाद. This is how statisticians write love letters.
You are three standard the top.
3 standard deviations above the normal. Now, why does this?
Rejected.
What are we saying here? What are we saying here? Now, let's.
99%. Rejected हो गया है.
When you have a normal curve, right? When you have a normal curve, in that normal curve, what we say is that I think I'll have it. Better to.
599.
Okay, we have talked about this. All of you should be okay with this first. Let's go one by one. I'll talk about the 3 standard deviation rule. This is the formula for finding out variance. How you find variance, and then you underroot all this to find out standard deviation. Don't care about this. I am not interested. You also should not. We're talking about the spread and how the spread affects all this, right? This you already understand. Which one do you think has a higher standard deviation? The one that is more spread? Higher standard deviation? Lower standard deviation. Right skewness, all of you understand now? Left skewed and right skewed. You all understand kurtosis also? Are we good till this point?
Yeah.
Right? Now, went too fast? It's okay, that's it.
You tell, was it fast?
What I want you to show is the standard deviation curve. I had one, but it was not A very promising one. So let us see. It's okay. If we don't have also, it's okay. So this is load. Now, think of it like this. In this particular thing, what we have is this is a normal distribution. There is a mean which will be placed here. This is a symmetric distribution. Both the sides are similar. Now the mean will be in the center, right? Mean. I'll not talk about median and other things. Right now I'm saying mean. Mean is also represented using mu. Mean is also represented using a symbol known as mu or x bar. I'll tell you when is it x bar, when is it mu. दोनों एक ही नाम है, एक घर का नाम है, एक ऑफिस का नाम, ठीक है? घर का नाम है x bar, दुनिया के लिए है official name. Now, when you look at this, we are saying that most of the data is here, right? And standard deviation is the spread, right? So there has to be some statistics, something, some relation of standard deviation to this. We say one standard deviation, two standard deviations, and then three standard deviations on either side. This is one standard deviation. This is two standard deviations, and this is three standard deviations. Now what we say is around, if the volume or if the area covered under this curve was how much? 1. Area covered under any curve is 1. Out of that, around 68% is covered within one standard deviation. If I tell you a data where I say that the mean age of this class is 24, standard deviation of this class says age is 1. What I say is 60% or 68% of the class will be from 23 to 25. So this is 24. One standard deviation is 1 multiplied by standard deviation, whatever. So if the standard deviation would have been 2, then this number would have been what?
26.
One standard deviation.
26.
Minus one standard deviation. So this number would have been 26 and this would have been 22. This would have been 28 and this would have been 20. This would have been 20. And this would have been 18. Standard deviation. Is this okay? Clear to everyone? Are you getting what I'm doing? Depends on standard deviation. Let's say the standard deviation would have been 4. One standard deviation would have been 24 plus 4. 24 plus 8. 24 plus 12. 24 minus 4 minus 8 minus 12. One standard deviation, 2 times of standard deviation, 3 times of standard deviation. Now the rule, the thumb rule says in a normal distribution, 68% of the data will be covered under one standard deviation on either side. ये भैया रूल है, ऐसा ही होता है. अगर सब कुछ सही है तो ऐसा ही होता है. शादी में सब कुछ सही है तो पति चुप रहता है. ऐसे ही यहाँ पर अगर सब कुछ सही है तो 68% डेटा -1 से +1 स्टैंडर्ड डिवीजन में आ जाता है. यहाँ पर we cover in this from this to this. Oops. From 2 standard deviation covers around 95% of the data. Right? There's again the matlab, if there are 100 students in this class, from 20 to 28, I will have around 95 students. Only 5 students will be outside. And then around 99.7 is covered within 3 standard deviations. Yes, sir.
You said like the class mean is 24 and the standard deviation is 4. Can you expand out what do you mean when you say standard deviation is 4?
Yes, sir. So the data is, let's say there are 100 students in the class. 100. I take their data, the age 21, 22, 24, 26, and so on. I add them all and divide it by 100. I get the mean, which is 24. Now, what is standard deviation? How are these numbers spread around this? How do I find standard deviation? If you guys don't mind, can I do some little maths? Once I have this, then I use the formula. Xi minus x bar. What is this xi? Xi is first value, second value, third value, fourth value, and so on. So 21 minus 24. Xi minus x bar square. So that I do not have any problem of negative and positive cancelling out each other. That is why I square. Look at this. You will see a little small variant of this. xi minus x bar squared. Right? Why am I squaring this? So that there is no negative. And then I do it for all. So very quickly we'll do it. 21 minus 24 squared. 3 squared is 9. 22 minus 24. 2 squared is 4. 0. Again 4. And so on. I get all of these. I sum them. Summation of all these squared values. So summation. Summation of these numbers.
300.
Divided by
100.
summation of these divided by total number of terms that I had. Now why is this n minus 1 also I'll talk. Total number of terms that I have. This becomes my variance. Now what is this variance telling me? If this is very far from this number will be high. Xi minus x bar square. So let's say this number is 100. 100 minus 24 squared will be very, very high. If all the numbers are close, if all the, one thing, very simple. If all the numbers would have been 24, 24, 24, 24, 24. 0. Variance is 0. Variance is 0 means there is no variability in the data. Variance is high, means the data is varying a lot. That is what it is telling me. In this, let's say my variance comes out to be 16 after doing all the calculation, the variance comes out to be 16, let's say. After doing all this calculation and all, I got 16. I say that this variance is not, it is a squared term. I squared it here, no. So the problem is that it is squared. In order to bring it to the same unit which was this, I will have to do a under root. That's why you see under root in the standard deviation formula. So this under root of 16 will be 4. On an average, this is for you to understand, not correct. For you to understand. On an average, the numbers are varying around 4 from the mean. Mean nikala maine meri class. My mean is 24. Now I'll say that if I pick random student, there is a very, very high probability that the student will be in between what to what range. So I'm saying because the variability is only 4, standard deviation is only 4. So if I'm picking any student, I can say that there's a 68% chance that this student is between 22 to 26. If the standard deviation is 2, not 4. If it is 4, then this number will be 20 to 28. And so on. That's what we are doing.
So when you were saying that the acceptable norm that the standard deviation is 1 and 68% data should lie in it.
I get where the doubt is coming from. Wait. Before anything else in this world, before we even go to the standard deviation and what all, I drew this curve. The answer lies there in this curve. The answer is that if your data is following a normal distribution, I'll come to that. Okay, we have 5 minutes. We'll not do any more concept. We'll just introduce a new concept and we'll just talk about that. Hold your thoughts till this point. Whatever we have discussed, mean, median, mode, standard deviation, variance and all, but just hold it till this point. Whatever I'm saying now, if it confuses you, just ignore it. But whenever you talk about data getting generated, what was data? Data was information on a variable. Now, whenever I am collecting information on a variable, the information can be of various kinds and types. For example, if I'm tossing a coin, when I toss a coin, the information will be either head or tail. Nothing else is possible. Whenever I am rolling a dice, the information can be 1, 2, 3, 4, 5, 6. Now, if the information is of a kind where I get only 2 outcomes, pass, fail, head, tail, lose, win, This particular data set that will be generated will be known as a binomial data. Why? Only two options. If the data is about occurrence in a certain time interval, number of times I breathe in 1 minute, on an average, number of times I breathe in 1 minute, number of cars parked in the parking lot right now, number of people walking across the street, number of students sitting in the class in a specific time interval. Whenever I talk about number of discrete hoga ye. This will be discrete. Discrete as in you will be able to count it, right? 10 people, I have had 20 breaths, 30, 50, 70 breaths, whatever. Number of cars parked are 80, 100, whatever. Number of students sitting are 10, 20, 15, whatever. Countables, discrete. This sort of a data is known as a Poisson data. Wherever we are talking about number of people walking in a barber's shop in an hour, number of people walking in a restaurant in an hour, right? Number of people walking in a restaurant in an hour, how will you write it? First hour, second hour, third hour, fourth hour, fifth hour, and so on. In the first hour, there were 70 people, second hour, 72, and so on. This is different from your head and tail data. Right? This sort of a data where there are only two possible outcomes is known as a binomial distribution. We'll talk about this in detail again. This is known as a Poisson. But when you talk about continuous data, such as height, weight, right, age, continuous means you cannot tell the exact amount at a particular point in time. If I ask your age right now, you can't tell. Even if you tell me that I am 24 years, 7 months, 3 days, 8 hours, 10 seconds, no. Gone. When you measure time on stopwatch also, you are only able to measure to the extent where you can. Second, nanosecond, second, microsecond, nanosecond, whatever. But it does not mean that the minutest possible measurement unit is nanosecond only. It will be way, way beyond that. You can't measure it. When you say what is the amount of water in this bottle, nobody can tell me exactly how much water is there in this bottle. You can't tell your age, you can't tell your weight exactly. If you say that no, the weighing scale is telling me my weight is 72 kgs, no. Because the weighing scale can only measure to this efficiency. It is telling you 72. Otherwise, your weight could have been 72.580. Okay, your machine is able to find out in grams also. Nanograms, whatever. Really can't. So this is continuous data. Whenever you have continuous data, where the numbers are in a certain range and most of the numbers will be around mean. Age, height data. Height, you will find most of the people in the country in between 5 to 60. There will be people who will be less than 5 also, people who will be less than 6 also, but less. Normally, it makes sense for me to have something like this. Age data in this class will be like that only. There will be somebody who is an outlier on the other side, but then most of them will be here. So then I can safely say that it follows a normal distribution. Normal, continuous, and like this. So now coming back to the example that we were talking. If I have a normal distribution, the property of a normal distribution is that in a normal distribution, 68% of the data will be in this range. One standard deviation on this side or this side. This is the property of normal distribution. Normal distribution ऐसा ही होता है. Normal distribution. अब आपका जो distribution है, if your data is following exactly this or not, is the question that how do you know this will follow this exactly? Because by nature your data is normal. If I tell you in a binomial distribution, the chances of occurrence of an event is 50-50. Now if you are doing head and tail, it will be 50-50 because it is the property, let's say. Right? So this is a property which says that irrespective of what, this is what it will be following. How are we?
It's basically an assumption based on.
It is not assumption. There are proofs for it. Because the shape that you see, no, this shape is specific to normal distribution, and it has been proven that age, height, weight, these all data, they follow a normal distribution generally.
What I'm saying is the word normal distribution itself is basically, that is the assumption, and then.
Oh, yes, very right. Yes, absolutely correct. What if, now the counter question that he can raise is, what if everybody in the class is 24 exactly? We were all born on the same day. I can't do anything. Then that's not a normal distribution. That becomes a uniform distribution. So the assumption is there that it should be a normal distribution. It is a normal distribution. Then only you can do this. If it is a normal distribution, we know that 68% is here, 95% is here, and the rest is here. Now, if you know that 99.7% of the data is covered in 3 standard deviations on either side, and if you're above that, now coming back to my love letter, not my love letter, the love letter. Now coming back to the love letter where the person said that you are 3 standard deviations above the normal. What does it mean? That 99.7 hata do bhai, you are amongst the 0.03 in this world. So you are special. That's what we are saying.
You are rejected.
So if we say the mean is X and the standard deviation of a data set is 4, are we saying that that is not a normal distribution? The data is not a normal distribution curve if we represent it on a graph.
No. Why not? Why not? Let's say you're saying that the mean is X. Any number X.
Yeah.
And you're saying that the standard deviation is 4. All that I'll say is the extremes that you're talking about is, let's say, X minus 12 on this side and X plus 12 on this side. One standard deviation will be X plus 4, X minus 4 and X plus 4. This will be X minus 8 and X plus 8. It cannot.
Okay, now I got it.
Possible.
So standard deviation being 4, like the number 4 is not the one you were talking about. So the one is the unit.
Yes.
And 4 is the number
Yes.
to it, the magnitude to it.
Yes.
Okay, got it.
When I said one standard,
I was confusing between 1 and 1 and.
What I meant was 1 multiplied, 2 multiplied, 3 multiplied. My standard. Standard deviation can be 100, 200, 500. It's only the spread.
That is why.
The higher the standard deviation, the more will be the spread. Right? So with this, the first class we'll take. And we'll be back in like how much time? Half an hour? आज तुम मेरे को
कल सुबह भी आप ही हो
कल सुबह मैं नहीं
9 बजे भी आप ही हो
नहीं आ रहा
नहीं आ रहे
आपने नहीं बताया मैं बता कल सुबह आ रहा हूँ मैं हाँ बताऊंगा अभी बताएंगे आई सरप्राइज पे सरप्राइज सरप्राइज तो तुम्हें